Yep. Oh there. Now, question of the week. The first question of the week. We are going to pick the most infamous question of JEE Advanced. This is the celebrity question. This is peak cinema question. Let's do this. I might try to solve this in less than 5 minutes. I won't be able to explain you this question because I'm just going to do it very fast. As fast as I could. That is my goal. I thought of explaining this. I recorded a video, but it's going to take a little bit more time. So basically this thing is also rotating. I will show you the diagram. Blah 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 blah. Now see, how is this is rotating with omega, this is also rotating. The option D says that find this rotating of this, like angular velocity of this one. So how are we going to find it? We got this as L, this is as a X, and this is as a 90 degrees A. Since these are like perpendicular 90 degrees, so this is the hypotenuse. X square equal to L square plus A square, L equal to root 25. You can see the question over there, and here it's going to be 25 A square, X equal to 5A. Okay, 5A, we got that. Now then, what more we are going to do? We have to find the time period, which is T equal to 2 pi by omega dash this one. So it is rotating. For it to make a complete circle, this will rotate in a complete circular motion. So that's going to be distance. Distance is phi, which is distance, which is complete rotation like this, which is phi a, circumference of a circle 2 pi r, which is 2 pi by phi a, which is 10 pi a, guys. This is the distance, and we want the time equal to distance by speed is v equal to r omega. We all know the formula, which is r is basically, guys, a, the radius. So a omega, we got the omega value, they are given in the question. So 10 pi omega, so omega dash is omega by 5. We got the option D, guys. Let's go. Now we have to find the angular momentum. Since this is rotating, I will draw it with another one. Yeah, wait a second. What the frick? Yeah. Since this is rotating like this, the angular momentum is going to be like this. And for angular momentum at the center of mass at the point O, since this is angular momentum is r bar cross mv, vm. So this is perpendicular to velocity. So angular momentum of that is going to be L naught. This is theta. This is the perpendicular. They are already drawn it. So here is 90 minus theta. This is theta again, right? So what will it be? This is 90 minus theta. This is theta. This is going to be 90 minus theta. Just remember that, guys. Okay. We have to find the LS, spin angular momentum. LS is basically I1 omega. I1 is m. What is the moment of inertia of disk? M r square by 2. We are in this case m a square by 2. Omega is omega plus this is 4m mass with 2a radius. So it's going to be 16 ma square by 2 omega. So the spin angular momentum will be 17 ma square omega by 2. Let's see if the option is there. 17 ma square omega by 2, the magnitude of the angular momentum of the assembly, the system. Okay, now we understood that the center of mass. Why do we need the center of mass? We want the LO naught value, right? So for this value, we are considering this whole system as some mass. If this is mass m, this is 4m, the total mass of the system will be wait a second. The total mass of the system will be 5m. Now we need our center of mass, the center of mass of the system. So what is the center of mass of the system? Which is this is m, and the distance from m and from the center is L. So ml, and for the second one 4m, and the distance is 2l. 4m plus 2l, 8l, so 5m. So it will be 9l by 5. We can see that from finding the value of center of mass. That's it, guys. We found the value. We will just substitute here. 5m, 9l by 5, and we want the v value. V equal to r omega dash, which is r is the center of mass. So v equal to 9l by 5. What is omega dash? Not this one. So omega double dash. We found the omega double dash for this. Now we have to find the omega for what? omega means omega double, this is omega dash, guys. Oh, wait a second. Yeah, this is omega dash, this is omega double dash. So how is the rotation from this axis we have to find? How are we going to find that? Omega double dash equal to, sorry, from here if we resolve this, omega double dash cos theta equal to omega dash, right? So what is cos theta? We can find that from the triangle. This is x, this is a, this is L. So cos theta, which is the hypotenuse, x is the hypotenuse, which is the adjacent, L is the adjacent, adjacent by hypotenuse, so a, right? Yeah, L is basically root 24 a by 5 a. So cos theta equal to root 24 by 5 and sin theta equal to 1 by 5. I hope you all understood this. Yep. So we got these values, and omega double dash is cos of theta, which is root 24 by 5, and omega dash is omega by 5. So omega double dash is omega by root 24. Good, we have found this. So 12 by 5 is the center of mass, which is 9L by 5 by omega by root 24. Now we just have to multiply 5. M 81, L square is 24, and A is A square omega by root 24 times 5. Now if we calculate this, the option C will not be the answer because of root 24 on the upside, and yeah, so that's why option C is wrong. Now we have to find option A, which is asking us about the z-axis, the angular momentum. Okay, we'll find that. Wait a second. This is LZ, we got the LO value, we got this value, this is 90 minus theta, this is theta, and this value will be L0 cos theta, and this value will be LS sin theta, because cos of 90 minus theta is sin theta, guys. Yeah, so LZ will be L0 cos theta minus LS sin theta, right? So why I said L0 is dominating, because if we look at it, this one is dominating that one. This is LS, this is L0. I hope you all understood that. So we just substitute the value, we find the cos of theta, we find the sin of theta. You guys calculate the answer. If the answer is going to be 55 mv square omega, option A is correct. If not, the option is wrong. So I hope you all understood how to do this question. I tried to do it really fast, that's why I need explanation. I hope you all get this. Watch the video in slow motion if you don't get this.